I'm your host, Grayson Brulte. Welcome to another episode of SAE Tomorrow Today, a show about emerging technology and trends in mobility with leaders and innovators to make it all happen. On today's episode, we're absolutely honored to be joined by PACCAR's Phil Stephenson, Executive Chair of this year's COMVEC. On today's episode, we'll discuss new technologies, evolving testing strategies, and what's ahead for commercial vehicles. We hope you enjoy this episode. At COMVEC 2025, you're not just attending a conference, you're stepping into the center of the commercial vehicle industry's transformation. Over 3 days, leaders from PACCAR, along with 60 plus executive council members from OEMs, suppliers, governments, and academia will tackle real-world propulsion strategies, battery degradation, and software-defined vehicle architectures. The agenda hits hard: zero-emission roadmaps, cybersecurity for AI-powered trucks, system-level electrification, and ADAS validation, all shaped by voices who build, regulate, and deploy at scale. If your team is serious about advancing technology, upskilling talent, and staying ahead of regulatory disruption, this is the room you need to be in. COMVEC. This is where the industry's next chapter begins. Do not get left behind. Phil, welcome to the podcast.
Thanks. Happy to be here.
It's great to have you here. PACCAR has a long storied history of building quality trucks. Trucks that scale, trucks that last, and trucks that perform at an extremely high level. Technology is changing. How is PACCAR currently thinking about new technologies, and how do you look to integrate them into your, let's call them your world-class trucks?
Yeah, well, the first thing is we're a technology company, but we're not technology for the sake of technology. You know, we're always thinking about our customers, how they use the trucks, how they can use them to be more efficient and successful in their jobs. So all the technology we develop derives from requirements our customers may have. And if you think about requirements, it can come from different ways they use the trucks. It can come from different regulations they have to face. There's a big transition in some of our markets from diesel to electric, and we want that to be as seamless as possible for our customers. So technology around batteries, electric motors, chargers, all those kind of things, for example, are things we develop and that our truck divisions implement and put in their hands.
And I want to highlight for the listeners, your trucks are used for on-road, and they're also used for off-road. They're in the Northern Dakota, in the Permian Basin. How do you make, or do you modify the truck for the off-road, since that environment is much different than going down the highway? What has to go into building that truck, because your customers have the needs for them?
Yeah, what's really cool about our trucks in North America, at least, is they're all built to order. So we don't build a stock truck. So when a customer comes to us and they say, you know, we're going to be using the truck in the oil field, or we're going to be using it for hauling goods on the highway, or we're going to be using it to collect refuse, whatever, we have a lot of options we can offer them. We offer different engines, we offer different suspensions, different transmissions, really everything. And of course, we have some options, some collections of options that have been successful for customers. And many of them have their own kind of baseline spec for the applications that they do. I did a calculation once, and you know, if you go to, for example, the Peterbilt factory and you look at all the combinations of options, there's something like 3 or 4 trillion different trucks they could build. And so we advise our customers. Our customers are also very smart in terms of what they need based on their experience. And then we build that truck for them.
Now, I have to throw another ingredient here. So the customer comes to you and says, okay, Phil, we like to build a truck, but we want to put battery electric in the truck instead of your traditional diesel engine.
Yep.
How do you do that? Do you have to re-architecture, or do you have a platform for that?
Yeah, so our strategy at the moment is that we will deliver a truck, which can be a diesel truck. It can be an electric truck. There are obviously a lot of differences in the technical content. For example, an electric truck has no engine, and it has a different transmission, and it doesn't have fuel tanks, but it has batteries. But our battery systems are designed to fit in a conventional truck, whether it's a cab over like we sell in Europe, or it's a conventional truck like we sell in North America. You would, if you looked under the hood of our electric truck, you'd see something that's shaped like an engine. But it's actually, it could be a battery. It could be all of the electrical components that go into the truck other than the main drive motor. And so we really make an effort to architect things so that it fits together and the truck is still usable like a regular truck. What we also do is make sure that the user interface, so the display in the cab, the way the driver selects reverse, neutral, or drive, All those things are very familiar to them. They don't look crazily different from a diesel that they've been driving. And we give them feedback in ways that make sense to them operating a truck, not just necessarily to us as engineers designing electrical trucks.
And then from an engineering perspective, batteries weigh more than your traditional diesel truck. If you have a single tank or a dual tank, how do you manage there for the weight issue? Do you try and use different materials, different batteries, so not as heavy as traditional batteries?
Yeah, with batteries, first of all, just a sort of a reference point, if you look at a Class 8 on-highway configuration and you want to compare the mass of a diesel to a truck with, say, 250 or 300 miles range, if you take all the mass of the diesel, the fuel tanks, the engine out, and you add in all the electrical components, you're adding typically about 7,000 pounds to the mass of the truck. So one thing is, if you have an 80,000 pound gross vehicle weight limit, we do get a regulatory allowance to go to 82, but still you've got 5,000 pounds to make up. And there is a point to where distribution of weight becomes important. We do typically spec a heavier rating front axle on those trucks because of that. But honestly, packaging is almost more of a challenge than weight distribution because the battery packs are still relatively large. And so we package battery packs on the rails. We package them behind the cab, all with the goal of not increasing unnecessarily the wheelbase of the truck. And of course, the weight distribution on the axles is important as well.
Do you see the battery electric trucks mostly be used for drayage, or do you see other applications that those trucks would go into use?
Well, at the moment, the range limitation versus weight, let's say, means that it's probably a little bit more economical to apply battery electric to trucks with a little bit shorter range. So drayage is an example. It's also important to think about the charging infrastructure. So a truck that returns to base every night only needs chargers at the base. If you compare that to one that's doing, let's say, regional haul or certainly long distance line haul, you need to have a reliance on the public charging network, which isn't so well developed a lot of places. So, we see more customers on the early adoption side from, let's say, regional haul to local pickup and delivery to things like refuse collection being the ones that are, let's say, adopting a little bit faster. We'll see. We're continuously working on getting batteries to be lighter, to hold more charge, and that gives us more range. And so the market will continue to evolve as the product continues to evolve.
Well, the refuse makes a lot of sense because it's going back to the same home every night. And it's in a constrained environment for the most part. And
electric trucks are quieter than diesel. So when you have a truck running through your neighborhood at 4 a.m, it's pretty nice that it's a silent electric truck rather than a combustion engine vehicle.
There's a lot of regulations around the United States now to ban the electric gas mowers. Mm-hmm. And move it to battery electric, where you're right, the town councils, in some cases the mayors, and the way it's structured, saying, okay, we're done with the noise. Do you feel with since there's this call it the local level movement to eliminate noise that could potentially accelerate the adoption of these battery electric trucks in those environments?
I think it could be one thing. At the moment, most of the pressure is regulatory and it's on CO2 emissions. Our trucks are quiet, relatively speaking, compared to the older days. The adoption of diesel aftertreatment system means we have quite a bit more muffling capability than we had when we were just running a muffler behind the engine. And there's a lot of cost associated with building an electric powertrain, which I think it'd be hard to justify just on the noise. It's typically around the economy, the local zero emissions, and the CO2 reduction. But yeah, it's a nice side benefit that they're also very quiet. Drivers love it, by the way. When we get electric trucks into fleets, drivers tend to gravitate towards them because it's very relaxing to drive a truck that's so quiet, and they enjoy it.
And then, do you also, when you're in an electric truck, do you get less vibrations than you would in your traditional diesel truck?
You get different vibration inputs. The challenge actually with electric trucks is there's so much less background noise. You start to hear other things and you need to address them. And so cab rattles and squeaks, we always put a focus on. but we've been forced to put more of a focus on it. And, I drive an electric car myself, and I've experienced this too, where I heard this terrible noise and I couldn't figure out what it was. And it was the garage door opener clipped on my visor rattling a little bit, and I could hear that. And so those kind of things are real, and we're chasing those things down in our electric trucks.
Well, it's problems for you to solve. Do you put those, the electric trucks, the diesel trucks, and perhaps other powertrains, do you put those through different types of testing at the PACCAR Technical Center where you're right, so the battery, okay, so all suddenly if somebody has a button to get into the yard and you start to hear that, and do you test all that stuff at the Technical Center?
We do have a battery test, which is specific to electric trucks, but a lot of it is derived from requirements that we have for diesel. With the idea being the customer wants to use the vehicle in the same way, and they want to be at least as satisfied, as, if not hopefully more, with the new products. And so in the case of buzz, squeak, and rattle, or noise, vibration, harshness, we have specific tests that we run. We have a road simulator, for example. It's a 6-post shaker, so it can actually impart shock and vibration and frame twist and all those kind of things to a tractor and a trailer in our lab. That's a great place with a low noise background where we can find those kind of noises and address them. But yeah, I would say anytime we have a product requirement, we have developed a testing requirement, a testing capability, and that's an ongoing escalation as we try to, continue to engineer more and more quality. And we really say, don't write a requirement for which you don't have a way of testing it.
So you have the 3 to 4 trillion different configurations. Do you put each configuration through rigorous testing, or is it just every time you introduce a new model or make a significant update?
So we can't possibly test trillions of trucks. We wouldn't have any for our customers if we brought them all here for testing, and we'd never get done. What we do is we have a couple of different strategies I can talk about. So one of them is the idea that you can get a lot of insight into how a whole vehicle is going to perform and how its durability is going to be by starting testing at the component level, working up to the system level, working to the vehicle level, and even testing fleets of vehicles, so that you can get as much insight in at the lowest level of complexity. And add to that, we do a lot of numerical simulation around structural analysis, thermal analysis, combustion analysis, all these kind of things. And that adds to your confidence too. So we try to be at the point where by the time you're doing a vehicle test on road, you're really confirming what you already know rather than trying not to find a lot of new things. Of course, we always do find new things. The road's a little different than the lab. But that's one thing, is really trying to get the complexity out of the problem and test at the lowest level possible. The other thing we do is we have what we call a parenting strategy. So when we look at what kind of test sample we want to take, we will take test samples and we'll apply testing profiles which are at the higher end of, let's say, difficulty. So we have a testing profile where we test as if we were a logging truck in British Columbia, fully laden, coming down a really difficult road. And so the BC logger profile is one of our durability profiles that we test a lot of vehicles on, even if they're not being designed to run in BC on a logging trail. And of course, we'll also test components on the trucks, which are, say, at the higher end, which are being stressed a little bit more, so that we know if that test sample passes that test, we know all of its siblings, which are being subjected to a little bit less load, also will pass. And that gives us the ability to get a lot of information out of a smaller number of tests.
Are there any limitations to what you can and cannot test at the technical center?
There are always limitations because there are always new applications and new technologies coming along. But I would say between what we have here and labs that we partner with for, let's say, less popular or common tests, and the testing that we do with actual customers before we launch the vehicle into production, we've got a lot of capability. We cover a lot of ground. So, if you were to visit the technical center, you would see we have a structures lab where we can shake cabs and frames. You'd see we have an engine lab. We have engine labs in Europe and in North America where we can test engines under all the conditions they'd see in the vehicle. We have a climatic chassis dynamometer where the truck can see temperatures from, minus 22 to plus 130 and wind speeds to 75 miles per hour and altitudes to 14,000 feet. And the list goes on and on. We have materials labs. And so we really do have the ability to test, like I said, component through vehicle level, all the different systems that are on the truck. And, when we need to go outside, we do. So we don't do electromagnetic capability testing or compatibility testing here in the lab because we only do it a few times a year. But we partner with labs that have that capability and can test vehicles of the size that we produce.
Is durability one of the key things that you're looking for when you're putting your trucks through various different tests?
Absolutely. Durability and uptime kind of go together. So our customers expect to be able to have the truck available anytime they need to use it. And they expect that, with proper maintenance, they can keep that truck on the road for 1, 2, 3 or more million miles. A truck typically goes through a first, a second, a third owner. So you think of the big fleets that are buying trucks, running thousands of them at a time for, say, 3 or 4 years, and then they'll trade that truck in, buy a new truck, and then that truck goes to a next application, might go to a regional haul, and eventually it may become a farm truck, but the expectation is if it's got a DOF, a Kenworth, or a Peterbilt logo on it, it's going to be a high quality truck that's going to last for a very long time.
That's what your name stands for. I know your name's PACCAR, but your name, if you speak to individuals that work in the trucking industry, stands for quality and durability. So you're based at the technical center down in Silicon Valley. You have the innovation center. I'm really curious, how do you complement each other since they're two centers of excellence?
I think of it sort of as a continuum from, new ideas that could be coming from startup companies or could be coming from our suppliers, which are also quite active in Silicon Valley, could be coming from universities. And how does that flow all the way to reliable, durable, high uptime vehicles that our customers expect? And so the Innovation Center is sort of our technical scout in the Silicon Valley and with the community. They're not all in the Silicon Valley, of course. There's a lot of technology development in Detroit and Pittsburgh and other places too. But they're kind of the group that's plugged into all the new technology that maybe even isn't used in commercial vehicles yet that can flow from other places. They scout that out. They do proof of concept work. They test it out. They partner with these companies and they say, hey, this is a thing that could be an idea. This could be practical for us. And handover then comes to the technical center. And I should say technical centers because we have an organization in Europe and we have an organization in India that do similar work to what we do. We'll typically take those technologies and put it into what we call a technology readiness level evaluation, where we look at, through a series of simulation and testing, how ready is this technology to go to production? And technology readiness is something that was invented by NASA in the 70s. And so we use that same methodology to get it to a point where we say, this is ready for implementation and production. We put that idea into what we call our product creation process, which is our development process of the truck divisions. And out the other end comes a truck off the production line, which has got some version of that technology now vetted, now ready for use, now expected to be a component of a high uptime, high reliability vehicle. So it's really a partnership of more than just the Innovation Center and the technical centers. It's a collaboration which runs for the truck divisions and the powertrain group as well.
Are the tech scouts looking for new technologies that will create value for your customers at the end of the day? Is that the overarching goal of what they're looking for?
Yeah. They're looking for things that will create value in the operation, minimize downtime, improve maintainability, all those kind of things. And of course, they're looking for technologies that will help us meet future regulatory requirements. So a lot of the work that we've done on safety and that we've done on electrification, even on future combustion systems, have come out of scouting work that's come from the Innovation Center and elsewhere.
Which brings up a really good point. So the Innovation Center is leaning in to find new technologies. Technical Center, you're validating and testing those technologies. So how do you as a company, PACCAR, how do you balance technical development in an environment where I'll call ping pong, where policies are ping pong, they're going back and forth in this game? How do you balance that? Because you can't go all the way this way, and then the policy changes like, how do you balance that?
Yeah. So, our approach has been to do a lot of things in parallel. but also do them in a very cost efficient way. And so, as an example, at the moment, we've got development programs working on next generation diesel, on electric for sure, and some explorations into, say, alternative fuels, for example. And they come and go depending on, potential of them for actually going to the market, regulatory pressure. But, we have a lot of technologies developed to the point, let's say to the point that would be appropriate for now, that we can switch on and bring into development, into production when the time is right. Current environment's a little bit interesting for electrification in North America, but it's going strong in Europe. And so we leverage the fact that we're active in multiple markets and we're doing development in multiple markets, always with the goal of commonality. So we can bring a technology into any of our vehicle brands and implement it in any market that we're active in.
When you're looking at alternative fuels, is that natural gas, liquid hydrogen? Is that what you were referring to?
Yeah, so we've offered the Cummins natural gas engine in our vehicles, and we still do. And so our approach there has been to partner with Cummins for natural gas. The volume of natural gas is pretty small for any one OEM. Cummins, of course, sells to multiple OEMs, and so that's been the strategy there. In the past, we've had partnerships on hydrogen fuel cells. So we had a pretty successful development partnership with Toyota. We had Kenworth T680 trucks with the Toyota fuel cell stack running in the ports of Long Beach and LA, running, actual deliveries for customers, including deliveries of Toyota cars from the plant, which was quite interesting to see. And we've had investigations into hydrogen as a fuel for combustion. So there was a European project in the several years ago, early 2000s, where we won an R&D award in Europe for our hydrogen combustion engine. So those are, those would be the main alternative fuels that we've been looking at.
From a driver perspective, what's the biggest between a battery electric, diesel, natural gas, and hydrogen fuel cell? Do the drivers, obviously, it's fun to drive battery electric. I own an EV, and so it's very fun. But do drivers, have they shared feedback with you on hydrogen fuel cells or nat gas if they like driving? Any feedback that they've shared with you?
Yeah, I think, natural gas is pretty established, and a lot of fleets are using it. There are a number of fleets that are 100% natural gas. It's very popular in refuse, for example. In some cases, the companies are recovering their own natural gas from the landfills that they operate. I think the feedback on natural gas has been that it's pretty much like driving any other diesel truck to the driver. The fueling is a little bit different, but it's relatively quick. And so that's pretty much mainstream. On the electric side, everybody likes driving them. They're quiet. They're instant torque from 0 RPMs. They're kind of a joy to drive. There, it's been more how to interact with the charging infrastructure. Little things like you have more braking when the battery is less than 100% full. If you've driven your EV after you've charged it full down a hill, that you got to put a little more effort into the braking. So there's a little bit of training there. On the hydrogen side, every fuel cell truck is a hybrid. There's a battery system there as well. And so there's some differences to how a hydrogen fuel cell truck drives when the battery starts out full to later on when it's not. And of course, fueling infrastructure is one of the things people have to get used to with hydrogen. There's not a lot of it. And there are different standards for the fueling pressure. All these things require some additional planning on the part of the driver and the fleet and when they're going to do that and where they're going to do that.
In your opinion, is then this infrastructure the biggest bottleneck to alternative fuels for that market to grow? Does it all come down to infrastructure at the end of the day?
It comes down to infrastructure, but infrastructure becomes less important if your application is one where you return to base at the end of every day or during the day. And if you look at adoption of electric vehicles, it's been strongest in regional haul, refuse collection, pickup and delivery, where the truck just relies on the chargers that are at known locations and doesn't have to rely on public charging network. With that said, the charging network is improving. So as an example, our our location in Europe is in Eindhoven in the southeast of the Netherlands. I was on a winter testing trip north of the Arctic Circle in Sweden earlier this year, and we drove the electric truck we were testing. We drove it from Eindhoven to Kiruna, north of the Arctic Circle, all using public charging networks. So that's a drive of must be at least 1,000 kilometers, if not more. We successfully drove that relying on the infrastructure. We've also driven test trucks from here in Mount Vernon, Washington to Montana, and testing locations which are not in the most populous areas, also just relying on public charging networks. So it is getting better.
It's getting there because when the infrastructure's there and then you eliminate the fear, you could see a reason why one of your customers, a large fleet, would then say, okay, we're going to do this lane, this lane, this lane, and go lane by lane.
Yeah.
Do you see the same way I see it from an adoption standpoint? Do you see it going on a lane by lane basis?
Yeah, I think so. It's a little bit chicken and egg too, of course, because the trucks will come once the infrastructure is there, and you don't want to build the infrastructure until there's going to be demand for it. But yeah, I think it's inching along. Those things are kind of working their way through. But yeah, I do see it in areas where the demand is enough to justify the infrastructure, because it's not just the chargers, it's the strength of the grid. Many places where you install a charger, you don't have the grid, so you need to build in a microgrid with some battery storage and maybe even some local generation, which is expensive capital project. You got to be sure that it's going to get utilized.
You use the term inching along. I'll use the term trucking along, because that's what you want. You want the trucks to keep moving. This year, PACCAR is the executive host for COMVEC. Thank you. Why? What is PACCAR hoping to achieve with this sponsorship?
Yeah. Well, first of all, we've been strong proponents of the SAE for decades. We were the executive sponsor of COMVEC actually 10 years ago as well. So, we see just the value of the SAE, the standards that the organization produces, which are a benefit to our whole industry, the educational opportunities for our engineers throughout the industry, and just the kind of collaboration that's possible. We're strong competitors with the other truck OEMs. But there are a lot of things that we do together which are pre-competitive or non-competitive at all. And, COMVEC also brings in off-highway and military applications as well. And there's a lot of carryover. There's a lot of work we can do together, learning from each other. The supply base supplies many of those sectors as well. So it's just a great opportunity to talk about technical challenges and solutions. And this year, one thing we're really excited about is we've got a whole day. Day 2 of COMVEC is really focused on the people aspect. So, technology is great, but you need people to develop it. People use it. And so there's a continuous need for education, starting in, elementary school through college and so on. But then you've got technicians that need to be educated in terms of tools to access the new technology, to service them. You've got mid-career people that want to make a change and stay relevant to how things are changing. And so we're going to talk a lot in day 2 about all those sort of opportunities for people development that are compatible with the technical development in our industry.
Do you feel that that's around exposing individuals to new tools or new ways of doing things? And especially we talk a lot about maintenance, because the maintenance is changing from an electric vehicle to a diesel to a nat gas to a hydrogen, or you put sensor, it's completely different. Is it kind of helping individuals develop or a new skill set or enhance their existing skill set?
Yeah, I think so. And of course, there are new ways of doing the same thing too. So there's been a lot of talk in the world about artificial intelligence, but the use of AI tools, the use of data science tools to get insight into information that we already have, but maybe just don't think about a certain way because it requires a lot of horsepower to do that. Tools for predictive maintenance using data science, or tools to streamline operations using artificial intelligence. These are all things that people can use once they've had a chance to think about them and learn a little bit more about them. So it's another great topic for SAE, and it's a great way to get people just familiarized and thinking about it and starting to apply it.
How is PACCAR currently integrating AI into operations today?
as I just mentioned, we use it a lot in conjunction with data science. So extracting trends, helping to look at appropriate times for maintenance. In the case that we have a need to run a campaign, let's say, to improve something that's in a vehicle, to select the vehicles, to do it in a way that those maintenance intervals are aligned with, let's say, oil changes or something we're going to bring the vehicle in for anyway. That's a great application. In operations, so in manufacturing, we're making a lot of use of computer vision alongside AI to do checks during manufacturing. Let's say are all the external lights installed in the right place and they have the right color lenses, or how does this wiring scheme look compared to the drawing, and using AI to identify features and match them up. So that's a big example now, and we'll continue to use it in a lot of aspects of manufacturing.
On the manufacturing standpoint, are you exploring using digital twins? And if you are, what type of enhancements from a productivity standpoint has PACCAR seen?
Yeah, we've always done a lot of simulation work alongside of manufacturing, and I'm a longtime simulation guy myself. I didn't realize 30 years ago I was building digital twins, but I guess I was at the time. But yeah, these tools that are available are something we're quite familiar with. They're all really there to improve our manufacturing efficiency and also to allow us to minimize downtime for our plants. When we want to make a change, we really want to be confident in it without spending a lot of time testing it at the cost of downtime to the factories.
At the end of the day, you want efficiency, and your customers want efficiency. Phil, in your opinion, what is the future of PACCAR?
Well, we've been around for 120 years this year, and we plan to continue. And our focus has been on commercial vehicles and really all aspects. So obviously, people know the truck brands. They may be less familiar with our PACCAR Parts division, which is a great company that gets parts to customers often in one day, sometimes less than one day. They're very focused on customer uptime. And so that aspect of keeping trucks on the road and keeping the customer moving is important. We will continue to have a finance division that helps customers to finance trucks, helps dealerships to finance inventory, has a leasing division that allows us to meet needs of customers that don't need to own a truck. So there are all these aspects around, moving of commercial vehicles to move goods. And I think we'll stay very focused on that. The technologies will change, and the customer way of using the vehicle may change. The regulatory environment will change, and we'll stay compatible with that and look to keep our customers profitable as we stay profitable.
In my opinion, you're going to keep building high quality trucks for another 120 plus years. As we look to wrap up this insightful conversation, what would you like our listeners to take away with them today?
Well, since we're talking about this in the context of COMVEC, if you like this discussion and you like these topics, you should come to COMVEC. And you should register for COMVEC and come for 3 really interesting, insightful days talking about topics around commercial vehicles with a lot of smart people from all over the industry. So that'd be my first thing. And then I think the other thing I would say, if people are watching this that are thinking about a career in engineering and in automotive engineering, commercial vehicles are really cool. They're some of the most complex, some of the most challenging applications of automotive engineering. So, if you're thinking about a career, give commercial vehicles a real thought when you're thinking about future careers.
Commercial vehicles are cool. As Phil said, go to COMVEC, learn, have really great, interesting conversations. You never know what you're going to learn, or it could turn into a career opportunity. You just never know. Sometimes you just have to show up. Today is tomorrow. Tomorrow is today. The future is PACCAR. Phil, thank you so much for coming on SAE Tomorrow Today.
Thank you.
Thank you for listening to SAE Tomorrow Today. If you've enjoyed this episode and would like to hear more, please kindly rate, review, and let us know what topics you'd like for us to explore next.
SAE International makes no representations as to the accuracy of the information presented in this podcast. The information and opinions are for general information only. SAE International does not endorse, approve, recommend, or certify any information, product, process, service, or organization presented or mentioned in this podcast.